Okay, fine. So in previous class we started to learn about the pin. We started to learn how the pin works and what are the way out, how to actually understand about the pin, and how to find out how much force is exerted, how much force you can apply till it's breaking. So we are talking about those things. So while we are talking about those things, I have briefed about two loading. One is UDL and another is VDL. That should be you. I thought you should also know. You all actually know that what is UDL and what is VDL. As I have told you that UDL stands for uniformly distributed load, and VDL stands for varying distributed load. So what happens is that in this section it comes with a UDL section, UDL. Now why it comes? Because this surface stays entirely contact in this surface, but in this surface this surface doesn't comes entire contact. That means there is something amount of deflection, that is there is some point of deflection for which we cannot say that cannot say that this is VDL, UDL, that is uniformly distributed load. Same goes for this. Same goes for the down system. So that means this one and this one. So what happens is that in this case and in this case, in both the cases we can find that we are dealing with VDL, that is varying distributed load. So and this is where we come in contact. We state it as a UDL. Fine. Now, did I understand? Did I give you an explanation what is VDL, UDL? Did I give you a brief explanation about it? Yes or no? Did I give any brief explanation regarding
UDL নিয়ে তো বলছিলেন।
Okay, fine. What is UDL and what is VDL? Let us make it very short. What is UDL? UDL stands for uniformly distributed load. Fine. Now what does that mean? That means let us consider this to be a beam. The load applied over the entire area from this, let this be the length L, so the load applied over here, let it be the X, let it be X. X load. In every point the load applied will be X. That means if you let us go for this one. Let me zoom it. If you consider in this point, it will be X. If you consider this point, it will be X. This point X, 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 this point X. That means everywhere the load applied is X, and it is uniformly distributed. Now you may ask, let me tell you, because you people are eager to know about those things, that's why I'm telling you. You may ask, sir, is it 100% possible to get an entire uniformly distributed load? No, we just assume that. It's a hypothetical thing. Now it's a hypothetical thing. Why I'm telling that? Because you cannot say that everywhere you can get exactly X amount of load. There may be somewhat plus minus. That means there may be some more deviation. It can be more, it can be less, but in general, in average, it remains to be X. That's why we consider this to be X. For example, Newton per meter. Now if it is in meter, if the length is in meter. Now you may ask, sir, how to make assumptions, how to draw a formulation, because it will make you confusion that, sir, what should be the formulation, what should be the your formula by which you can get this one. Now for that we have one formula that is called uniform distributed load formula. So what we do is that let us go for just So what happens is that we can actually draw a conclusion, and the conclusion is that the load, the entire load is distributed from the center of the object. Let me tell you, the load is concentrated on the center. Now the question appears, is it actually comes from center? Does it actually comes from center? Let me tell you, absolutely not. Absolutely not. You may ask me why I'm telling you, why it is not possible. Why it is possible? This is why I'm telling you that, because the thing is that it is the possibility of doing this is very less. Why? Now the question appears because how to make you explain that one. This is an ideal phenomenon that the load is applied x, as I've told you, it's the amount of load in average, it is x. Now here comes, how can you represent it mathematically? This is the which comes in the main problem, where the expression breaks down. Now you may ask that how, sir, you can say that this one. Now let me tell you, we assume that. Now to make it very simple, we assume that the load applied is from center. The entire load of that is the load over here, this entire load applied is from the center of the beam. That means this will be L into X Newton per meter. Sorry, it will be not meter anymore. Now this will be only L into X Newton. The problem. Now you may ask, sir, why are you telling that this is the problem? Let me share something, a fact about you, that how can you tell that the thing is that the load is applied in entire section can be concentrated in a single point. Can anyone give me an answer? Why? Can you actually digest it? Yes or no? Can you actually digest it? Is it possible? Is it possible? আমি আনসার চাইছি, আমি তোমাদের জিজ্ঞেস করতেছি, এই টোটাল লোডটা ডিস্ট্রিবিউট করা আছে একটা ফুল লেন্থে, হঠাৎ করে আমি বললাম যে নো ইটস নট লোডে, এটা তো আছে, ইট ক্যান বি রিপ্রেজেন্টেড ইন আ সিঙ্গেল পয়েন্ট।
মোমেন্টাম ব্যালেন্স করলে অ্যাবাউট দ্যাট মিড পয়েন্ট।
নাও এখানে মোমেন্টাম, উই আর নট টকিং অ্যাবাউট মোমেন্টাম, উই আর নট ব্রিংিং anything, we are just telling that the load will be applied in the center. Now let me tell you why I have done that. Because have you drawn the SFD and BMD diagrams? SFD and BMD diagram in solid mechanics class? Have you done that?
ফুল ফর্মটা বলুন একটুখানি।
Shear force diagram, moment bending moment diagram.
Yes sir,
haven't you drawn about these things? Haven't you studied about these things? Uniformly distributed load over there?
Yes sir, পড়েছিলাম UDL.
Yes, this is what. Why I'm doing that? There must be some explanation. Why I am concentrating this entire load in a single point. Just give me 5 minutes. Just give me 5 minutes. I'm coming back. Let us get back to the point. So what happens is that in this manner, we could actually draw this one. Actually, we could make the assumption. Now let me show you the assumption. Why I'm doing this? There's a certain big reason behind it. The reason is that if I don't represent in this manner, that is in a point load, I cannot explain the BMD or SFD changes. That's why we do this one. Now one more thing is that, as you can see, let me show you one more thing. Can you see there is a written point P, a point P? Is it visible to you people? Can you see? Can you see this one? Now that means there may be a question, sir, how can you write this as P? Now the main reason is this one. The main reason is this one, but we don't actually go in inner depth of this one. Why we write P, why we write P by 2, what is the reason? So there are a lot of difference. So what we do is that for understanding this thing, for understanding the loading behavior or bending purpose of this pin, what we do is that we consider this to be a uniformly distributed load. So what we do, if we go back, let us come to this way. Now as you can see, this is uniformly distributed load where P load is applied. Now what we can do, what we have done is we have made it, we have dissected in two ways, from here to here. Fine. Now now what happens is that even in this point we are considering only a point on one side. So why I am considering, because assuming this pin to be a symmetric. Now you may ask, sir, this is not symmetric because we are having a head, this one. So we are as if for now we are ignoring this one. As if for now we are ignoring this one, and we are assuming this this entire loading to be symmetric. What happens is that for that, if we consider the half of this one, that means the other half will not be present. Am I right? Am I right or wrong? I don't know. Now why I am doing that? Now there's a one more theoretical point or practical explanation of this. Why am I doing this one? There must be some reason why I am making a calculation doing on the half of it. Now let me tell you one thing. If you say, if you can prove this, if this half is safe, that means the other half will also be safe. Can you get my word? If you can say this half is safe, that means this half is safe, that means the other half will be also safe. That means there will be double safe. There will be win-win situation. So what you can do is that you can actually take this part. That means here the loading, here this will be changed in this manner. Let me show you in my board. Just give me a sec. Let me prepare my board. Okay. Just give me a sec. Let me prepare my board. So share screen, start sharing, start now. Is the screen visible to you people? Is it visible?
Yes, sir.
Can you see the Jamboard?
Yes, sir.
Okay, fine. Now let me make you one thing explain. Let me explain you the thing. The thing is that okay, what you can do is that we can actually see that here a beam is there. Let us consider a beam. The loading is applied in this manner. Now to get maximum safety, what we did is that we divided this in two halves. Now what we have assumed that if one side is safe, the other side will also be safe. Did you got my word? If one side is safe, that means the other side will also be safe. That means we don't need to calculate the other side. So what we have to do, we have to just do some calculations. Now what we have done the calculations, let us get back to the calculation and let us get back to the thing. Now let me draw this one again. So as you can see, as we have seen in the book of the calculation, that is p by 2, and this is p by 2, and this is p. Now if I consider to make it half, what will happen? Can anyone tell me? If I take the half of the portion, that means this position, that means this, in this position, this part will also get half. That means this will also get half, and in this load will come p by 2. Am I clear? Am I clear or not? So what you can do, there are many methods to do this one. So what we can do is that, so what we'll do, we'll make this diagram in this way right now. This will be p by 2, this will be p by 2. Now clear? Is it clear? Now what you can do is that you can, as we know, this from we have to get back to this point also again, because we know the length from here to here is b, and from here to here it is a. Here to here it is a. Since we are bisecting it according to its symmetry, what we can do is that we can, from here we can see that from this point to this point the length will be b by 2, and this will be a. Fine. So let us understand the phenomenon. As we know that the load p by 2 will be concentrated on a single point. That means on the center of it. That means let us make it more simpler diagram. Let it be p by 2. And this to be also p by 2. P by 2. Now as we know, let me make it very shorter for you. Okay, fine. I need to draw something, just that will make you more, it will explain you more. B by 2 Z, and from here to here let us consider it as Z, or let us consider it as P or capital Q, and now is it clear to you all that how it is happening? Is it clear? Is it clear or not?
Yes, sir.
Now what is happening is that, now try to understand, let me make it more clear, more explainable to you people, that you, as you can see, this p by 2 is concentrated on this area. That means we could change it to the center of this point, as we have understood in the previous, just today itself. Same, that means the value, we know that this length is b by 2. Do you know that we know that this length is b by 2? That means the center will be, that means if I consider this as to be the z, that means from this point to this point the length. So what will happen, z will be nothing but z is equals to b by 2 divided by 2, that is b by 4. Fine, is that clear? Is that clear? বোঝা গেছে কি বোঝা যায়নি? Is that clear? I need response. Here to you.
বলুন স্যার এই জায়গাটা।
বলছি যে আমরা এখানে দেখো এই যে পুরো লোডটাকে আমরা একটা পয়েন্ট লোডে কনসিডার করছি। ইয়েস অর নো? করছি তো? সো আমরা কি করতে পারি, পয়েন্ট লোডে কনসিডার করা মানে কি, পয়েন্ট লোডে কনসিডার করছি মানে কি, আমরা একটু আগে বলে আসলাম যে এই যে পয়েন্ট লোডে আমরা কনসিডার করছি এটা হাফ হবে, মানে কি এই যে পুরোটা যদি বি বাই 2 হয়, এটা যদি বি বাই 2 হয়, কেন তাহলে এটা বি বাই 2রও হাফ, তাহলে এখানে তাহলে আমরা এটাকে নাম দিলাম জেড, তাহলে আমরা বললাম বি বাই 2 ডিভাইড বাই 2, তাহলে এই জেড এর ভ্যালুটা কত হলো, বি বাই 2 বাই 4। নাও আমরা এই জিনিসটা সম্বন্ধে আমরা পড়িনি, যেটা হচ্ছে ভিডিএল। ভিডিএল এ কি হয়, ভিডিএল আমরা এই জিনিসটার সম্বন্ধে একটু পড়িনি। ভিডিএল এ কি হয়, ভিডিএল এ কোশ্চেনটা আসে কি, ভিডিএল এ হয়টা কি, আমরা দু রকম ভাবে ভিডিএল কে কনসিডারেশন করি। না, ভিডিএল মানে কি, varying distributed load. Now this is length L. Here you will find max load, and here you will find minimum load. Now you may ask me, sir, is it termed as max load and it is termed as minimum load? No, we just what we do is that we assume it that the average load to be x. Again x Newton per meter. It may be meter, it may be feet, it may be yards, it depends on what you are using. So meter. So what you can do is that, now you may ask me, sir, where shall I put the point load? That means where shall I put the overall load to explain this part? So what I can do is that this is done by this way. This one, let this is be x Newton meter or Newton, sorry, let it be x dash. Let me give me x dash, not x dash, because there will be some changes from x to x dash. So what will happen, from here to here it will be L by 3, from here to here it will be L by 2L by 3. Now let me, L by 3. Now you may ask, sir, at what basis you have done that? There may be a question from your side, so don't worry, I am giving you the answer. This means, now try to understand, from the lower end it will be 2L by 3, and from the greater end it will be L by 3. Is that clear? Is that clear to you people? So what you can do is that I am giving you one disclaimer. The class may the network connection may get off because it's raining heavily over here. So if it goes off, don't worry. I'll be waiting for the rain, then I'll start again. Now, so what you can do is that, from now, as you can see, that just observe it, the Q direction. Q is from the highest one. Q is from the highest one. Is it wrong or right? Pratham, it is from the highest, correct?
highest কি বললেন?
highest magnitude or highest value, as you can see. This one is the highest, this one is
আচ্ছা
the
আচ্ছা
lowest.
হ্যাঁ
Now replicate these things over here. So see, this one is the highest, correct, and this one is the lowest. And from here we have considered this load to be over here. So what would be the length of q? What would be the length of q?
কিউ এর কাছে L/3 হবে।
Q is equals to
A by 3.
a by 3. Okay, very good, both of you, very good. Now a by 3, what is happening is that now we have got this one. Now what we'll do is that we have to proceed furthermore. So how we can proceed furthermore? For proceeding furthermore, we need to know about the bending stress, sigma b. How many of you know about sigma b, bending stress? Anyone, does anyone knows about sigma b, bending stress?
স্যার আমি জানি না স্যার।
ওকে ফাইন, অন্য কেউ জানো? সলিড মেকানিক্সে পড়েছিলে বেন্ডিং স্ট্রেস, মনে আছে কাউ? ডাজ এনিওয়ান রিমেম্বার?
স্যার লাস্ট টাইম স্যার সলিড মেকানিক্সটা খুব ভালোভাবে স্যার পড়ানো হয়নি।
আচ্ছা, নাও লেট মি গিভ ইউ দ্য ফর্মুলা, ডোন্ট ওয়ারি, দিস ইজ ভেরি ইজি। এম বি ওয়াই বাই আই। In sometimes in some book it's not written as I, it is written as J, so don't worry, it's the same thing. Fine, don't worry. Now let us understand what is most. This is termed as bending stress. Bending stress. Now MB is nothing but your bending moment. Let me write it once more. MB is equals to bending moment. Fine. Y is neutral axis. Neutral axis. And I is termed as your polar moment of inertia. Clear? Is that clear to everyone? Just give you a second. But as I have stated you earlier, it's a very easy subject, so you don't have to worry about it. So the thing is that we have at first we have to find out what is MB. Next we have to find out what is Y. Next we have to find out what is I. Now before getting to this all things, we have to just see the diagram again. Now what is MB? Bending moment. Now why I have drawn this one? Now there is a question between you people. Sir, why you have drawn these things? Why you have made such things so much complicated? I didn't made it complicated for it is not done intentionally. It is done for to understand the bending moment. It is only done to understand the bending moment. Bending moment. Am I clear to people? Is it clear? It is only done to understand the bending moment. It is done to understand the bending moment. How you can do? Let me show you how you can do that. Okay. Now, as we know, let us get very clear. As we know, from here to here, or here, it is P by 4, it is B by 4, and load is P by 2. Is it clear? Next, there is one more load over here, and the length from here to here is A by 3, and this is also P by 2. Is it clear? বোঝা গেছে কি বোঝা যায়নি? এতটুকু বোঝা গেছে কি বোঝা যায়নি?
A/3 আচ্ছা হ্যাঁ
A by 3. হ্যাঁ বলো
এটা কিউ এর জন্য ছিল তো,
এক্স্যাক্টলি কিউ
রিডিং
জন্য,
লোডটার জন্য।
হ্যাঁ হ্যাঁ এক্স্যাক্টলি কিউ, ইট ওয়াজ নাথিং বাট কিউ। I have just written in the I have just written in a simpler form. It is nothing but the value of q. Fine. Now you are asked to find out the moment. What will you do? You are asked to find out the moment. How you can find the moment? So how you can do is that you will go for the section formulas. Now how many of you remember BMD, bending moment diagram? How many of you know? I mean the just about the brief knowledge. How many of you remember the brief knowledge about কাদের কাদের মনে
ক্লকওয়াইজ
আছে?
মুভমেন্ট, অ্যান্টি ক্লকওয়াইজ মুভমেন্ট ওগুলো
হ্যাঁ এক্স্যাক্টলি মনে আছে কি?
ঠিকঠাক মনে
বিম
নেই,
নিতাম,
বুঝিয়ে দিন।
বিম নিয়ে এসে একটা এটাকে আধে করতাম, সেকশনিং শিখেছিলে? সেকশন করে করে বের করা প্রত্যেকটা পার্ট, এটা করিয়েছিল, করানো হয়?
এটা আমি বলতে পারবো না, বাকিরা বলুক।
বাকিরা তোমাদের কি বলতে পারবে? সেকশন করে করে দেখিয়েছিল যে এই সেকশনে এত বেন্ডিং, এই সেকশনে এতটুকু বেন্ডিং, এটা কি দেখানো হয়েছিল? ইয়েস অর নো বলতে পারবে?
না মনে হয়।
না ঠিক আছে, কোনো অসুবিধা নেই।
না না স্যার দেখিয়েছিল ভাই।
দেখিয়েছিল?
দেখিয়েছিল, হ্যাঁ স্যার দেখিয়েছিল।
মনে আছে কি?
না স্যার
মনে নেই। না আমি একটা সিম্পল ভাবে বলছি, সেকশন মানে we are considering, আমি একটা ছোট করে বলে দিই, the thing is that the value, the section is that it is so complicated as it is so shown that it is very complicated, but it is the most easiest thing. Now you can, if you consider this is a section, let us consider xx, that means you will do a calculation for this point and you will not do a calculation for this point. Let me write this in another one. That will be A. So you will do calculation for this one, and for this one you will not do calculation for this one. After calculating this point, you will do the calculation for this one. That is let me preface it. You don't have to worry about section and everything. I'm just telling you the idea. This is nothing but doing calculation in each part. I am doing a calculation at first in this part, then I'll do the calculation on this part. If there is any load, will not consider while calculating this part. If there is while calculating this part, will not consider load over here. That means the thing remains same, just it gets changed. Fine. So what you can do, let us go for here. We don't have to worry about it, we just have to do a simple calculation. What we'll do, let us consider this point. Let me get this one. Let us consider this point and let us find a moment. Let it be O. Fine, let it be O. So what, sorry. So I'll be finding a bending moment at point O. Now as you can see, MO is equals to P by 2 into what? Plus P by 2 into what? Now can anyone tell me why I have given plus and plus, why both are positive? Can anyone tell me? Any answers? Why both are positive?
কারণ যে এই দুটো ফোর্স অ্যাপ্লাই হচ্ছে ওই দুটো ওই ক্লকওয়াইজ যে অ্যান্টি ক্লকওয়াইজ ডিরেকশনে মুভ হচ্ছে দুটো।
Perfect,
মানে স্যার
perfect.
সেম ডাইরেকশনে হচ্ছে তাই
Same direction. If it is a clockwise, it will be entirely clockwise. If it is a anti-clockwise, it anti-clockwise. That means আমি একটু বলে দিই তোমাদেরকে, এখানে একটু তোমাদেরকে বলে দিই। তোমরা একটু অনেক কেউ তোমরা most of you get afraid that sir, is anti-clockwise always positive? No, it's on you. It's on you. If you consider anti-clockwise as positive, if you consider the convention as a positive, it will be positive. If you don't consider anti-clockwise as positive, so it's on you. It's entirely on you. The magnitude of the thing will not change, because now the most important thing is that any calculation what you do in design or drawing, the thing is that we are calculating the magnitude. We are not going vectorically. That means we are calculating in scalar form. That means if it's a negative or positive, that will not make any problem. But if you are considering in vectorical form, here comes, if you are negative, then it will go behind it. If it's a positive, it will come in. So the consideration of positive clockwise and anti-clockwise is entirely on you. You don't have to worry about it. Now let us write it. M O is equals to P by 2 into A by 3 plus P by 2 into B by 4. Now here question can come, sir, how you can write this one in a single stroke? Is there any logic behind it? Yes, the logic is that, let me show the logic. The logic, let me change the color. This is going anti-clockwise, this load, compared to this point. Similarly, this load is also going anti-clockwise compared to this point. That's why I have written A by 3 into just give me, let me change the color. A by 3 into P by 2, as you can see, as you can see over here. Similarly, you can also see that P by 2 into B by 4 into B by 4, as you can see over here. Is it clear? Is it clear or not? Now next is the Y. Because considering Y is the neutral axis. This had been taught in your moment of inertia chapter. What is the neutral axis? That makes everything visible or something. Nothing but you have to just see one thing, that the diameter of this pin is D, and the neutral axis will be the center. Now you may ask me, sir, why you have just considered this to be a neutral axis? Because the neutral axis, because if you roll this pin also, you will get the same effect. Am I right or wrong? If you rotate this along its axis, then also you will get the same value. Right or wrong? Right or wrong?
মানে আপনি বলছেন মানে স্ক্রিনের বাইরের দিক থেকে আমি ভেতরের দিকে,
হ্যাঁ, আমি যদি এই রডটাকে ঘুরিয়েও দিই, আমি কিন্তু ভ্যালুটা সেমই পাবো, কোনো কিছু চেঞ্জ হবে না। তাহলে আমার নিউট্রাল, তাহলে কোন অ্যাক্সিসটা নিউট্রালি কাজ করছে, কোন অ্যাক্সিসে কোন
এই সিলিন্ডার যেটা আছে ওটার যে অ্যাক্সিসটা,
axis system. So what I can do, I can write D by 2. Why D by 2? This is D and this is D by 2. Consider, understood? Yes or no? Now last but not the least, since it's a cylinder, we should know how to find the moment of inertia. So for that we don't have to derive it, we just have to write the formula. I is equals to pi into d4 d4 by 64. Is that clear? Is that clear? Okay. Now what happens is that, now if after plotting this one, after just a second, oh, my net after putting the value of I or J as well as of this MB or MO and Y in this equation, let me show the equation, this equation. So what I can get is that I can get a value. So let me show the value, just give me a sec. Present now, here we go. So what value I can get is this one. Is it visible to you people? Is it visible?
No, sir.
Okay, stop it. Is it visible right now?
Yes, sir.
No, sir.
Okay. Is it visible right now? Right now?
হ্যাঁ হ্যাঁ
Now.
দেখা
No.
যাচ্ছে। Yes, sir.
হ্যাঁ এখন তো
আমি
দেখা
পাচ্ছি না।
দেখার কথা তো।
এবার এসছে, এবার এসছে।
হ্যাঁ, now after putting this all the value you will get this one, this thing. So after that you can find this one. Now here comes the twist. This is the end of the this is the end of your finding the diameter of the pin. Now as I have told you, small d is a critical part, so you have to be very much cautious regarding it, how to find it and how to not to find it. Now after that you will find you will be finding a value of d for you will be finding a value of d in four ways. That means you will find a value of d from here, from this equation. Next you will find a value of d from this equation. You will be finding a value of value of d from this equation. You will also find a value of d from this equation. That means let us consider this to be d1, this to be d2, this to be d3, this to be d4. After that you will compare d1, d2, d3, d4. The value, the maximum value, the maximum magnitude of d4 the maximum magnitude of d, that means from either d1, d2, d3, d4, any one of them may have the maximum magnitude of d. So what will happen, that would be the diameter, that will be considered as the diameter of the pin. Am I clear to you people? Am I clear? Now after that what we do is that let me complete it in a simpler way, so such that we can go for in the after lunchtime we'll do a simple sum, and we'll go for our software session also. Now what we can do is that, as you can see, area is equals to b d naught minus d. So what does that means? What area does that means? This means, as you can see, this is the I. Now we have to consider, since this is a hollow area, we will not consider as an area. So the area will be this part and this part. Am I clear? Am I clear or not? So what happens is that since we know that this from this point to this point it is d naught. It is d naught. Now you may ask, sir, what is the value of d naught? Do we have to find out? No, it's not a big deal. What you can do is d naught is equals to 2 times of d. Fine. So what you can do is since you can see this is a rectangle, so you know that this from this is d naught, and from this is d. If since it's an I end, this will be b. This will be b. So what you can do is that area A is equals to b into d naught minus d. Is that clear? How did I find out the area of this shaded region? Is that clear or not? Fine. Now since we know that at first we'll consider as a tensile load, we'll find the maximum tensile load. Now we will be given with the load, and since we have find out the dimension of d naught and d as well as b, so we'll put over here and I'll get a value of this one. Similarly, this goes for the shear also. We'll also do for the shear, where we'll be putting this P by 2 and P by 2. Now, why it is by 2 and by 2? What is the main reason of it? Now, at last you will get the same formula like the tensile loading only. As you can see here and here, these two formulas are the same. Now, why am I doing this one? What is the main reason behind it? The main reason behind it is, why it is half. As you can see, half. So as you have, that's why it is termed as half. Now, similarly, we can see that the applied load is also half, as you can see, as you have seen in the earlier calculation. Fine. So that's why what we do is that we put P by 2, and we also divide it as half. So after that we can find tau is equals to P by B d naught minus d. Fine. So next is that for the fork end, this is for the I end. Now you may ask for the fork end, what will happen? Now for the fork end, there is nothing, there will be nothing change. So let me get the fork end. Let me show you the fork end. That means the fork end. That means this nothing will change. Nothing will change. This will be d naught. This will be d naught. From here to here it is a. But since it is both, it will be 2a, and it will be the diameter will be also d. So what will happen? I could get this one. Let me get back to this one. The formula will remain same. And I could get that sigma t is equals to nothing but 2a. In place of b, I'll put only 2a, because the same thing remains same. The cross section remains same, and the change is only on this one. That was for I end it is b, and for the double I end it is a plus a. That's why it comes 2a. So similarly for tau, we don't have to consider. So that gives an answer. Now, last but not the least thing. But thing is that comparing this value with the allowed value, we'll see if the value of this one is less or not. This one. Similarly, this one, and as well as this one. If the value of these four quantities are less than the allowed stress, that means the design is entirely safe to be used. Is that clear? So don't worry, we'll do a sum that will make you a sense, because you may think that, so what are the things what comes in my mind. So don't worry, we'll go for this one. We'll do the sum, and I'll make you and explain it, as well as I'll give you a note. Don't worry, I will get a note. You will get a note where I'll be giving you the way out how to do this one. Plus we'll do the software part also. So we'll see everyone at 3. Till then, take your lunch, have your lunch, and get ready for the next class. Fine. And fine.